Hi, everybody. Thank you for coming to our talk today. My name is Archana Sridhar. I'm a product owner for the Puppet Server team. Today, I have Kevin Corcoran and Chris Price with me. They're on the engineering team for Puppet Server. So today, we would love to walk you through what Puppet Server is, what we have done over the past year, some of the new and exciting features that we will be coming up with, kind of walk you through those. Talk about some of the roadmap items that we have on our radar for the next year or plus, and then open it up for questions. That's kind of what we were planning to do. Before we get started, just a quick show of hands. How many of you are using Puppet Server today? Fantastic, great. How many of you are on PE Puppet Server? Already, excellent. That's awesome to hear. So for those who didn't raise their hands, just a quick recap of what Puppet Server is. So it was designed as a next step in the evolution of Puppet Master. So as opposed to the old Apache implementation, this is a drop-in replacement for the web server functionality of Puppet Master. So that's what it was designed as. And then why Puppet Server? So some of the motivations behind developing a Puppet Server. First of all, unification. I talked about as a replacement of the web server functionality. There were many different approaches that were used or that are being used in certain situations where Puppet Server isn't used, and the Puppet Server was meant to be a replacement for those. And the unification also meant that we could provide more support, better documentation for the one implementation that we have, and that was one of the motivations. Performance. You've heard about it before. As soon as we changed the implementation from WebRick Apache Passengers, the performance drastically improved. We have heard this from some of our partners. We have heard this from some of the members in the community, so that's fantastic. And better performance, scaling, availability are all the things that we absolutely require today and more every day. So that's kind of a basic requirement moving forward. Ease of install, primarily for open source. This is a huge deal. We have heard this every time that changed everything and things like that. So Puppet Server is very easy to install on open source and contributes to better implementation further down. Composable services that are built on top of Puppet Server are very helpful in achieving certain things. And this is one of the important ingredients of our architecture portions of today's conversation. So without further ado, I would like to request Chris to take over and talk about the Puppet Server architecture, and then we'll go from there. Chris, over to you.
Thank you, Archana. All right. So if any of you were here last year, I gave a talk about the architecture. I'm going to just do a little bit of a recap of that in a little less detail. So if you're interested in getting more detail than I give today, you can go back and watch the talk from last year. We also have a few blog posts about it. But I'm going to try to breeze through it pretty quickly so that I can save some time to talk about the cool new features that we've been working on. Also, we just announced Puppet Server. The first open source release of Puppet Server was at PuppetConf last year. So today is kind of like our birthday. Woo! Okay, so this diagram here shows what the old architecture looked like. And this is Puppet Enterprise 3.3 and before. On the left-hand side there, you see all your Puppet agents. On the right-hand side here, you see all of the Puppet Master Ruby code on disk on the server. In the middle, you've got Apache running with a Passenger plugin, and Passenger is responsible for spawning all of these discrete MRI Ruby processes that are actually, each one of those then loads up the Puppet Master Ruby code from disk and then uses that to handle the requests that come in. So the color coding here was sort of intended to highlight which parts of this stack that we as Puppet Labs engineers kind of own and have control over, and which parts we don't. So all the agent code is ours, all the master Ruby code is ours. But in the middle here, there's a whole lot of code that we didn't really have a whole lot of control over. And so since each one of these discrete Ruby processes didn't really have any way to coordinate or observe state of what was going on in the other Ruby processes, it was really limiting in terms of being able to add caching to improve performance, being able to track what was going on in the system as a whole. So we started looking into ways to improve that. And one of the themes that I think is starting to come out of this in several of our server-side pieces is that it's kind of a transition from Puppet Labs building our applications on top of other open source applications. And it's kind of a shift away from that and towards building the Puppet Labs applications on top of open source libraries. So we're not trying to reinvent any wheels here, but if we can use libraries instead of applications like Apache, it gives us control of the process from beginning to end. So this is some of the technologies that are in the new stack. So the main programming language we're using for server-side stuff these days is Clojure. It's a Lisp implementation on the JVM. And the web server that we're using is Jetty, which we embed into the JVM process. Jetty has been around for a long time, used in a lot of production and deployments. So it's very battle-tested, high performance. And Clojure, these two we basically took from the success of PuppetDB, which we launched about 3 years ago and had great experience in terms of performance and scalability with that. So it was just pretty logical choices. Plus, Clojure is just really cool and fun to write in. And then JRuby is a library that we embed in our process to use to be able to run the existing Ruby code from inside the JVM. This is our obligatory inception slide. When we first introduced PuppetDB, I guess 3 years ago, Deepak gave a talk about it and talked about why we chose the JVM. And then I gave a talk where I showed a picture of his talk. And then Kevin gave a talk where he showed a picture of my talk. So you can just stay tuned for next year. So this is what the new stack looks like. So as this is PE 3.7 and later, and all of the versions of open source Puppet Server basically look like this. So we still, on the left, have the same code that we had before for the agent. On the right, we have the same code that we had before for the master, but we've kind of swapped out this middle piece. So the purple box here in the middle now is all our code. We have control over everything that's going on in here. We've got the embedded Jetty server. We've got a little bit of Clojure code that we use to kind of map the requests to the right destinations. But by and large, like the vast majority of the business logic is still coming from the same exact Ruby code that we had before. So it's not really a drastic change in the behavior of the system. The interesting part of this slide is we have this pool of JRuby interpreters, which you can think of as sort of little JRuby VMs that we can instantiate and manage inside of the process. It's very similar to the way that Passenger was spawning a bunch of discrete operating system Ruby processes, but we can control them now inside of the code, and we have a lot more flexibility about what they're used for, how many of them we have, things like that. As an example of sort of taking advantage of some of the new architecture, in PE, the first versions of PE where we shipped with Puppet Server, we have this metrics service that we added that runs inside the same container with the rest of these things. And so the metrics service can see what's going on with all of the rest of the components in the system. It knows exactly what their state is, how healthy they are, and it gives us the ability to start collecting a bunch of metrics about everything that's going on inside your system and surface that data to you outside of the process in different ways so that you have a much better way to diagnose and tune your server and see if you have bottlenecks or tuning improvements that you can make. You might have seen the word Trapper Keeper appear on a few slides prior to this. Trapper Keeper is our open source Clojure service framework that we wrote. It's basically just a platform that we use to build other server-side applications on top of. It basically began by just taking some of the common things out of PuppetDB, like the Jetty implementation that we knew we could use for a lot of other things, and just kind of rethinking how we package them so that they can be shared across all of the new services that we're building in Clojure. So Trapper Keeper allows us to share code across all of our new services. It allows us to have a common configuration and logging syntax across all of the different server-side applications and services that we're building. Whereas in the past, I think in Puppet Enterprise, each service had a tendency to be a little bit of a snowflake in terms of how you configured it and where its logs went. Now this battle is not over yet, but we're well on our way to sort of consolidating that and giving a much more consistent feel for how you interact with those things. So Trapper Keeper also moves us towards a more service-oriented architecture. the way we built Trapper Keeper, we have a system that we can use to generate RPMs and debs, just package files for you to install on your various distros that contain a large number of discrete services, like all the services that make up the Puppet Master or all the services that make up the PE console. But Trapper Keeper allows you to, via a configuration file, basically turn those services on and off depending on what you need on a given node. So for example, if you had installed that Puppet server package on several nodes, you could go onto some of them and turn off the certificate authority so that you have one central one to use. And we're planning on using that capability to do a lot more interesting things in terms of giving you a lot of choices about how to scale across multiple nodes with different services in the future. So now I'll talk a little bit about some of the key differences between Puppet server and the passenger-based master. So performance improvements, performance and scalability was something we focused on a lot at the very beginning. I think we're all kind of on a little high right now because on the way to the talk earlier, we ran into the Walmart folks in the hall that gave their keynote this morning. And they came over and told us, like, when we got past 30,000 nodes, passenger just kept falling down, and we had to keep restarting it with mcollective like 5 times a day. And we finally just switched to Puppet server, and now everything's just working. We were like, yes. So pretty psyched about that. Ease of installation, Archana mentioned this already, but we really want it to be as simple as yum install Puppet server service, Puppet server start, and that's it. And you've got basically a production quality server rather than a lot of that finagling you had to do to get the previous setup off the ground. This is the key difference between the two is the way that we run the Ruby code. So I already mentioned we're using JRuby to run the Ruby code in this server, whereas the old system would shell out to your operating system MRI Ruby. We found almost no cases where there's some Ruby code that runs in one and not in the other. We've had very little compatibility issues between the two, but there's one little gotcha, which is that there are some gems out there that have C++ or C native extensions to them. And so when you install these gems on the system Ruby, they compile some C code that does the implementation work under the scenes. And JRuby can't run those gems. Now we've also found that like basically for every gem that has a native extension like that, there is an equivalent JRuby version, often with the exact same API. So it's really just a matter of choosing the JRuby version of the gem rather than choosing the native version. But it is something you have to be a little bit aware of. And it means you kind of have to quarantine your gems. So you've got like one location where your system Ruby's gems go, and then one location where your Puppet server gems go. And so to help with that, we introduce a command line command called Puppet server gem. It's really just a tiny wrapper around the normal command line gem tool that everyone's used. But it calls into our embedded JRuby interpreter and puts its gems in a nice, safe place that's only used by Puppet server. In terms of tuning, the tuning considerations are very similar between the old system and the new system. In Passenger, you have a tuning setting that controls how many of those Ruby processes it will create on the operating system. We just have a configuration setting that controls how many of them we create and put in our pool inside of the server, but very similar concerns there. And then there's a setting that you can use in Passenger to say, after this Ruby process has handled n number of requests, I want you to just kill that process and start a fresh one. And the idea behind that is that if you have a long-running Ruby process that happens to have some kind of memory leak somewhere, then over time you'd use up all the RAM on the server, which is not a good thing, obviously. So we have a similar setting for Puppet server where you can say that any given JRuby instance can only handle this number of requests, and then it'll be flushed from the pool and we can free up all the memory that was associated with it. Now, normally and hopefully you never need to use this setting. Like we don't ever have to use it in any of our long-running test environments or anything. But it's important because Puppet is really extensible and any Puppet module may have some Ruby code in it. And we obviously can't control the whole breadth of all that code in the world and know whether any given module might have some kind of leak in it. So this is just a little bit of a safety hatch in case something like that's happening. And the last big difference that I'll talk about is the certificate authority. In order to make the SSL stuff compatible with Jetty, we had to basically rewrite the certificate authority logic in Clojure. The old master has some Ruby code that he uses for that stuff. We now have Clojure code that we use for it. The design of it was really, really focused on backwards compatibility. We use the same file format, the same directory structure, the same, everything should be exactly the same so that you can actually just take an existing passenger system and just like shut down the service, install Puppet server, and everything should just work. But it's kind of an important detail to know that it's not using the same Ruby code for the CA in case you ever get into any situation where you're having to troubleshoot something like that. It's just a good thing to know. And we're really excited. We're up to almost 20,000 installs of open source Puppet server. We see that number climbing steadily, and we're really excited about that. We hope if there's any of you out here who haven't tried it yet, you'll give it a shot. Puppet 4, you've probably heard a lot of talks at the conference touch on some of the really cool new features in Puppet 4. As of Puppet Server 2.0, one of the main things that we did in 2.0 was introduce Puppet 4 compatibility. So there's a lot of new language features that you can take advantage of, like the type system and the like support for lambdas and things like that. So that all comes with Puppet Server 2.0. One of the things that happened in Puppet 4 is there's a new URL structure that the agents use to talk to the masters. And hopefully this is just kind of a plumbing implementation detail that you never really have to deal with directly. But what we did is the way the URLs were structured before was really inflexible, and it made it really hard for us to evolve them and change the APIs at all without breaking backwards compatibility. So we wanted to change them and basically put a version number in them so that we have a much easier path towards introducing new APIs, changing existing APIs in the future without breaking backward compatibility with older agents. In the process of doing that, we broke backward compatibility with older agents. But as of Puppet Server 2.1, we have a compatibility layer in there. So Puppet Server 2.1 can accept requests from Puppet 4 and Puppet 3 agents, so you should be able to use both. That feature is not available in the passenger master, so you have to use Puppet Server if you want to support both kinds of agents. And that's enough for me. Now we'll get into some of the interesting new features that we've been working on, and for that, I will hand it over to Kevin Corcoran.
Thanks, Chris. So I'm really excited because on my very first day at Puppet Labs over 2 years ago, Chris sat me down and told me about this really cool idea he had for a new feature in Puppet Server. Well, Puppet Server wasn't a thing at the time, but the idea was around. It was called file sync, and that's what I get to talk about today. But before I get into that, or what it does, what it is, I want to talk about the problems it solves. And so to start, let's talk about how you scale your Puppet master. So this diagram shows the normal way of doing that. Instead of one Puppet master, you have multiple Puppet masters. One of them is designated as the master of masters, or the MOM. The others are called compile masters because their main job is to compile catalogs for agents. And the agents are, instead of talking to just one of these masters, they're all talking to a load balancer, which is going to distribute the traffic among the masters. So this works, and I'm sure that some of you in the audience are using a deployment like this. So that's cool, but it introduces a new problem that you don't have with a single master. And that problem is about the Puppet manifest, right? So at its essence, what the Puppet master does is compile catalogs based on the Puppet manifest code on disk. When you've got one master, that's fine. When you've got multiple masters, there are now multiple copies of the manifest code. And so you have to worry about keeping those in sync. If you don't, you basically lose all ability to predict what happens during an agent run. Because an agent's talking to a load balancer, which is directing that traffic back to a Puppet master, and you have no idea which one it's going to be. So if those manifests are not in the same state, all bets are off. Good luck, right? So this is the problem. But it's actually kind of a cool problem. It's the kind of problem I like to work on. So along with that fundamental problem that file sync solves, it addresses some additional questions around managing Puppet code and managing Puppet code at scale. First of all, how do I deploy code without breaking something? if you go on to a Puppet master and just throw new code in Etsy Puppet Labs code, you run the risk of breaking something, right? You're essentially changing the manifest code out from underneath the running Puppet master. And that's, if it's reading that code when you're changing it, again, good luck with what happens. So the fundamental problem there is that there's no way built into Puppet to deploy code atomically. How do I ensure that new code is live? What about caching? Who likes caching? Who likes having to worry about invalidating a cache just to get something to work? Yeah, nobody, right? If you saw Ryan's demo during the keynote yesterday, you saw that he sort of sneakily ran a little script called reset-environment-cache.sh like 5 times during the demo. That's because Puppet has this thing called the environment cache, which on a per environment basis caches the contents of all the manifests for that environment in memory. So if you're deploying new code, you have to worry about whether those manifests have been cached, whether you need to invalidate that cache. It all sounds like kind of a pain in the neck to me. Finally, how do I know what state my code was in when something happened? So let's say you're looking at an agent run that failed. You're looking at it in PuppetDB or the PE console. Right now, there's no way to know what state the manifest code was in when that failure occurred. FileSync addresses that. So enough questions. Let's get into it. So fundamentally, first of all, what we've added with FileSync is that compile masters can now ask the mom if there is a newer version of code available than the one they have. Most of the time, the mom just says no. And as you can tell, I had our visual design team at Puppet Labs up all night working on this diagram for me. So there's a client and a server component to FileSync. The client runs on all the masters. The server runs just on the mom. But it's really important to note that there are no additional processes introduced with FileSync. So there's no additional services you have to worry about managing or anything like that. It's also very low overhead, both in terms of CPU utilization and memory consumption. So you shouldn't really even notice it's there from an operability standpoint. So most of the time, compile master phones home, says, hey, mom, is there new code? Mom just says no. Until a couple things happen. The first thing that has to happen is that new code has to be placed in the staging directory. Staging directory is a new directory that we're introducing as a part of FileSync. And the reason is that that gives us the ability to do atomic code deployment. We no longer are simply changing manifests out from a process that may be reading them. Second thing that has to happen is you have to hit this publish endpoint, which FileSync adds to Puppet server. It's worth noting that this is all entirely optional. So if this seems like a pain in the neck, you don't have to worry about it. You can keep using Etsy Puppet Labs code the way you always have. You can keep throwing code right in there, willy-nilly. And things will still work as they always have. But if you do that, you will not get any of the benefits of FileSync. So after those 2 steps happen, the compile master again asks the mom, hey, mom, got any new code for me? And the mom says, yes, I do. So the compile master immediately fetches that down to its local file system. But it doesn't deploy it into the live code directory immediately. There's a discrete sequence of steps that it goes through. So the first thing that happens is that any incoming requests from agents are queued. And again, the reason for this is atomic code deployment. We're just going to park those requests and say, hold on a sec, we've got some new code to throw into place, we'll get to you in a moment. The requests don't fail or anything, we just hold on to them. We let any requests that are currently being processed finished. And then we deploy the new code into Etsy Puppet Labs code. It's worth noting that we do this as fast as we possibly can. This is a performance critical operation because while we're doing this, the system is from an external perspective, stalled in a sense, right? Agent runs aren't completing while this is happening. So deploying the new code from the staging directory to the live code directory has to be absolutely as fast as possible. And we went to great pains to optimize that code as much as we could. After that, we invalidate that pesky environment cache, and then we let the request handling resume. So this is pretty cool, right? Especially the part about invalidating that environment cache. It's kind of like having your cake and getting to eat it too, right? Like, so now what you should do with file sync is set environment timeout to be unlimited. Leave the caching on all the time. You get the maximum performance benefit from it. You never have to worry about invalidating it because file sync takes care of that for you. And you can be sure that any code you deploy is live immediately. Pretty cool. So the last question I posed was, how do I know what state my code was in when something happened, when an agent run failed, say? So since we now have this notion of code deployment built into Puppet Server, we can do things like generate an authoritative identifier for that deployment event. So we've done that. We've called it Code ID. And the first thing that we're doing with Code ID is stamping it into the catalog that the agent receives from the master. And Code ID is fundamental to direct Puppet, which Deepak was talking about this morning in the keynote. Thanks for stealing my thunder, by the way, Deepak. Yeah. But we've got a lot of plans to build stuff on top of this in the future, like direct Puppet, probably exposing this in the PE console as well. From an integration perspective, I mentioned the two things that you really have to do are throw code in the staging directory, publish it to file sync. In a lot of cases, we don't actually expect users to be doing that. If you saw the code management talk yesterday, the new code manager is going to do exactly those two things for you. If you're using R10K and you want to keep using R10K, it's going to be really easy to configure R10K to hit file sync when it's done putting code onto the MOM. And anything else, right? Like, all you got to do is put it in the right spot and make one HTTP request. Finally, one of the themes of like our back-end development on Puppet Server and other services at Puppet Labs over the past year or so has been giving our users increased insight into what the heck these processes are doing. We have some really cool metrics in Puppet Server, which Archana is going to talk about shortly. And for file sync, we have this status endpoint that returns a bunch of data about what's going on the server, what state it's in. For example, the last time a compile master checked in with the MOM. And this is really just a start. We've got some pretty cool ideas of what we can build on top of this, like command line interfaces. We talked about pushing this data into something like Logstash and making it possible to sort of track an event through the system, starting with a code manager run and flowing all the way through file sync. So we're excited about what we're going to be able to build on top of this. And that's file sync. To talk about more roadmap stuff, I'm going to kick it back to Archana.
Thank you, Kevin. All right, opportunities, challenges, ideas for future, that's what we want to talk about in our roadmap section. Obviously, file sync, once it goes out to production, we'll have some specific improvements that we would want to bring about, and Kevin already talked about some of those. Other than that, we have some other exciting work that's already in progress. One of them is the new HTTP authorization system. This was also introduced earlier today in the roadmap conversation. So Puppet uses HTTP under the hood for its API. So we need some way to authorize those URLs. And currently, there is a Ruby-based system that is available, but with more endpoints moving into closure, and we would need some other implementation to fill the gap. And in order to do that, we have created a closure library for authorizing the HTTP URLs. And in addition to that, it is embedded or wrapped up in a supported Puppet module for managing the rules. So what this does, obviously, is it's a machine-friendly, node-friendly, human-friendly way to manage the authorization of URLs. So that's something that we are introducing as part of this. it does provide better debugging information. So if something does go wrong, where did it go wrong, and what can we find out about that? And that will be available with this as well. So the first revs of this is already under works, and we are excited to bring that up. Obviously, the other best part is that if any other Clojure application that needs a way to authorize the URLs can use this within PE. So this is kind of a shareable service that is up there and available. And then future potential integration with RBAC. So RBAC, as many of you know already, provides authorization for node groups and business logic and things like that. But if there was one converged way to manage all kinds of authorization, that's kind of where we want to take the future. And this kind of paves the way for a more converged authorization management. And that's what, it's not part of the first rev, but we do want to work towards that as part of our roadmap. And last but not the least, on this one, I do want to give a huge shout out to Breeze Figueroa, who is one of our very valuable community members. He was one of the very first to contribute Clojure code, and that's what this is based on. And he's very generous and supportive and collaborative for us and our team. We've worked together with him and had conversations about the implementation. And thank you very much, Breeze, for your support. I really appreciate it. And then, not to mention that such community contributions are always welcome, and we look forward to more. Favorite topics for many of us in the room, metrics. Puppet Server provides a lot of data. So we have two different challenges. One is providing more specific data around JRuby health, providing more specific metrics around it. And the second is how the metrics are provided. So one of the things that we want to work on is develop kind of developer dashboards, which can be accessed by hitting the server directly. And then those can be evaluated to see, hey, how is everything going? Is something going wrong? If something is going wrong, what is going wrong? And kind of analyzing that at a very high level. So in order to solve that problem, we want to work on developing some developer dashboards and provide these there. So one example is the JRuby health metrics, as you can see here. If this looks similar to what you see in PuppetDB, it is similar, but it is different metrics. And it kind of gives you a snapshot of how all these metrics are looking at any given point in time. This is something that we are working on and is not currently available, but look forward to getting this out there. Similar to this, we also want to provide, like I said, some developer dashboards around what you can see here is a top 10 request list of incoming HTTP requests. So what is more resource intensive, how many are coming through, and things like this. We think that this is very valuable if they are more grouped together and presented. In addition to the incoming requests, we also want to show such top 10 metrics around Puppet functions that are used in catalog compilations, Puppet resource that were used in the catalogs, and then outgoing HTTP requests. So these are going from Puppet server to PuppetDB or node classifier, and so how are they looking? So those kinds of metrics. So that's what we want to be able to show. And we think it'll add a lot of value. We have gotten some good feedback around it. So one other thing that I do want to highlight, everything that I've talked about until now focuses on better operability of Puppet server. What this means is, how is this looking? How can I make this better, faster, perform easier, and then lay the foundation for future features that we want to bring about. And along these lines, we talked about the dashboard, the developer dashboard, and then certain availability of metrics via JSON or HTTP endpoint. So what this means is we expose those metrics through JSON, which you can utilize to develop further code and develop actions on, hey, something is going wrong, so do this type of a thing. So that's something that we would like to work on as well. Improved Graphite interop. So we are sending a ton of data into Graphite today if any of you are using it. So what this requires is some handheld tuning post it goes into Graphite. We would like to prune the data before it goes into Graphite, kind of group them properly so there's no further handholding required or less handholding required when you go into looking at the data. Furthermore, if possible, if we want to introduce some configurability, so that way you can pick and choose what is important to you for your implementation, for your organization, so it becomes more relevant. Reduced memory usage and startup time. We constantly explore possibilities and opportunities to improve these. As part of everything that we do, we check and see if there is any possibility to reduce the memory usage, and we fine tune it, and we want to continue along this effort. Introducing some debugging, introducing some breakpoints and seeing why something went wrong is obviously very important. We have heard this loud and clear from our professional services team, from our education team, from our open source communities that we need more CLI tools for debugging. So that's on the list as well. And then we talked about unification earlier, unification into the new implementation that we have. So one of the things is to remove the old code that we have out there for WebRick Rack. Remove that from our implementation, so we have one more supported area of code. Okay, so that was the list of operability improvements. The next set is the certificate authority improvements. Chris mentioned earlier, consolidating all the endpoints into Clojure. That's something that we would like to do. That is from a certificate authority perspective. And then there are currently 3 subcommands that give some, subset of help around certificate authorities. All of those are useful, or some of those are useful in certain situations. We do want to make sure that we kind of collect them all and have one subcommand to rule them all. Isn't that what everybody wants? But yes, that's on our list as well. And then improved support for elastic environments. So we know that in EC2, it is kind of complicated to authorize and deauthorize nodes, and it gets cumbersome. So we want to focus on improving the support in the elastic environments. High availability. So currently, one of the things that we want to do is separate the CA service from the master service. So that way, there is an easier possibility or a better, more persistent possibility to provide high availability for certificate authority. And that's just the first step in how we can set that up for the future. And there will be much more to do on this end. So this is just a brief overview of what we want to do on the certificate authority side. Everything in the roadmap is what we really want to do, what we have gotten a lot of feedback on, and we know that this is absolutely valuable. But what happens in our roadmap is it's a constant prioritization exercise. We hear from you, all of our customers, we hear from the community, and we hear internally as to what other features are getting developed and how we would need to prioritize what we have on our roadmap against things that are getting into our list. So we have to constantly prioritize. It's an iterative exercise, and everybody here agrees, but we do want to get these out the door as soon as we can and get it into your hands. So there's that. And here is our team, our awesome Puppet server team. And on behalf of everybody, we want to thank you for being here. And I'll open it for questions.
Something in front of you.
Oh. Uh-oh, it's Nan.
I'm running.
We're in trouble.
We're not in trouble. So out of curiosity, you showed in the catalog now there is a code ID.
Yeah.
So regarding the code ID, is that something I can retrieve later on? So if I know the code ID, and is it like in the logs? And if I know what the code ID is, like if the system moved on, can I get that catalog again? Thanks.
Yeah, great question. It will be in logs, and I think I actually forgot to mention this. Thank you. You're like a plant, I swear. So we're going to be adding an endpoint to Puppet server that for a given code ID will give you the manifest at a specified path at that point back in time. So this is going to make it possible to basically walk backwards in time along your manifest code, compile that catalog.
What I meant is besides the code, can I get because the client, like some people may say, hey, I rolled forward, can I get the previous catalog again? So I'm just curious, do you guys have any thoughts or plans on getting not just the code back, but the catalog back as well?
So the code ID is already, as of this release that we're talking about here, going to be stored in PuppetDB as part of the catalog there. As for storing historical catalogs, that's a feature I believe is on the PuppetDB roadmap, but I think that would be where you would go to get older catalogs. We've been bouncing around some ideas about the ability to actually do a full catalog compile from the historical code, since we now have it around, like a live compile rather than one that has been stored in PuppetDB. But that's like kind of just fancy, crazy brainstorming stuff right now. We haven't really like gotten too far into the implementation details of what that would look like.
Oh my God, it has to be on the other side of the room, doesn't it? Cardio.
So the atomic code deployments, and that sounded really cool. Can I do that with a single master and code manager, or do I have to have two for some reason?
Nope. You can do it with one master, and that will happen out of the box in the upcoming PE release.
Sweet.
Yeah.
With regards to file sync, is there a concept of having multiple masters of masters rolling it out to their submasters?
There's not currently. There's just a single master of masters. I don't know why you would want more than one, but it's an interesting idea.
Redundancy, data center separation.
Yeah, yeah.
Damn it. I mean, your call is important to me. Please stay on the line.
So this is a file sync question. You mentioned that when there's a code change of some sort, then there needs to be some blocking on agent requests.
Yeah.
Is there any danger of any kind of splay that's built into the enforcing mode being rubbed out by just having a thundering herd effect once the code's done being retrieved from the master of master?
I don't think so. That period in time in which we're blocking requests should be really quick, actually. So not like we're talking minutes or something here. So it should be almost imperceptible from an external perspective.
Okay, so just a couple seconds.
Yeah.
Hopefully
Thanks.
much faster than
Yeah,
that.
hopefully less than a second.
Another thing that we've had conversations about is the idea of changing display behavior on the agent so that the clock starts ticking after it completes a run rather than being on like a fixed clock interval. So that way, even if like one run got held up for a little while, like you'd still be waiting 30 minutes for to start the next one instead of it being at a fixed clock interval, if that makes sense.
Travis.
Have you guys talked about or thought about any possibilities for the compile masters to be a canary-style testing and pushing out that code, waiting for that to make sure it actually works, and then across all, or is that up to us to make sure we push good code? And if so, I'd love to actually find a better workflow to fix that.
So, I mean, I think that kind of, yeah. I would say no in this phase of the release, no. We're basically just rolling out the code. But as part of, like, we're really viewing this as a piece of foundational technology, like the ability to keep version history of the files plus the atomic code deploys. It gives us the ability to start exploring some things like strong consistency across all of the masters, or like something like you're saying, where you have a slightly different rollout pattern for how you get code to different masters, where you haven't tackled any of that yet, but this is kind of a framework that we could theoretically build something like that on top of.
All right, I'll come back. Your call will be answered in the order in which it was placed.
For the publish endpoint that you showed on the file sync service, is that asynchronous? And if so, is there an easy way to like subscribe to an event or something and get the status back when it's done and see what failed?
It's synchronous. So the publish is actually very quick. The propagation out to compile masters is the bit that's asynchronous. And I think the question of like, how do I know when my code has actually been deployed everywhere is a really good one. And that's kind of what we're hoping to answer with like the status endpoint that I showed and maybe pushing that data into Logstash or something like that.
So it would be like polling the status endpoint at this.
Yeah, at this point in time, for the first iteration, yeah.
Thank you.
We maybe have time for one more.
Yeah, so back to the file sync stuff. How do you make sure that all the masters are in sync? Because you're polling to know if there's new code to download, something like that.
So I think that question comes down to strong versus eventual consistency with the code on all the masters. And right now, for this iteration, it's eventually consistent.
Okay, so you can't guarantee that a node can apply a catalog and download files to another master and get a different version of that file?
Right, we can't guarantee that yet.
All right, that's time.
Thanks
everyone.
Thank you. Appreciate it.